Alright, hey guys, this is Miss Gallant. I just wanted to do a few, just kind of some examples of finding angles. I know that we've been kind of stuck on a few of these, and I just kind of wanted to do a video of all the basics. Okay, so we're going to start with triangles, and really and truly, if you can remember that all triangles, the interior angles of all triangles add up to 180. If you can handle that, you can handle anything. So let's stick this under here. All interior angles add to 180 degrees. Okay. So the measure of angle A plus the measure of angle B plus the measure of angle C should always equal 180. Okay. All right, so then I have a few mid-segment problems with some extra angles thrown in just for fun. And we want to find the measure of each missing angle. We're given that this angle is 56 degrees. We're given that this angle is 144 degrees. So my go-to advice on here is, yes, look at the whole picture, but kind of take some time to just look at different individual pieces. So if I cover this up, I have one triangle. I have that this angle is 56 degrees. This angle and this angle we don't know, but I know if I add this angle plus this angle plus this angle, I should get 180 degrees. Okay, so we can handle that in a minute. Now let me cover this up. If I look at these two angles, angle 2 and 144, so this angle and this angle, well, they form a straight line, and we know that straight lines add up to equal 180 degrees. So the measure of angle 2 plus 144 equals 180 degrees. Okay, because that forms a straight line. So what I can do is I can subtract 144 from 180, and that should give me the measure of angle 2. So let's do that. Let's do 180 minus 144. And the measure of angle 2 ends up being 36 degrees. Okay, so angle 2 ends up being 36 degrees. Okay, now I'm actually just going to make a little table that has all the angles I'm missing. Okay, so we have that angle 2 is 36 degrees. Okay, let me get my sticky and cover up again. So now I have just a little bitty triangle. So if I want to find angle 1, well, I know that these three have to add up to 180. So I can do, let's scoot around. What I can do is add these two together. So 56 plus 36. I get 92. All right, so I get 92 for these two. And then if these have to add up to 180, I've got to do 180 minus 92. That gives me 88 degrees. So that's my missing angle. So I'm going to pull this apart, and I can look at this one of two ways. Well, actually, it's the same way. I don't know why I said one of two ways, because my brain is not processing things today. All right, so if this is a mid-segment, which it is, because it is cutting this piece and this piece into cutting this piece into two congruent pieces, and this side of my triangle is cut into two congruent pieces. That's what these little marks are for. So this is a mid-segment, which means this line is parallel to this line. All right, so let's ignore this side for a second. I've got two parallel lines and a transversal, which means this angle and this angle are corresponding angles. So this angle is going to be congruent to this angle. 2 and 3 are the same angle. So angle 3 is also 36 degrees. All right, so now let me cover up this side. Again, we've got, actually let me cover up all of that, because we don't want to look at angle 1 because angle 1 is not formed with one of these parallel lines, so I want to cover that up. Okay, so I have two parallel lines. Here's my transversal. Angle 56, or this angle that measures 56 degrees, corresponds with angle 4. So that means this angle and this angle are congruent. So angle 4 is also 56 degrees. And it's just because these two are corresponding, they're congruent. And then we have angle 5. So angle 5 and angle 56, I'm going to cover this up. They are a linear pair. They form a straight line. So kind of like we did with 2 and 144, we're going to do the same, and we're going to find angle 5 here. So this is 180 minus, do I have enough room? Let me bump this up, minus 56. And that's going to be 124. Okay, and we found all our missing angle measures. And yeah, and basically we just use the fact that straight lines and triangles all add up to 180 degrees. Okay, let's look at this little mid-segment problem. So just, this one doesn't have any angles. This is all sides. Okay, so what we know, and we actually want, what we want is we want the perimeter. I'm going to make this a little more challenging. We want the perimeter of triangle JKL. So this whole triangle, we want the perimeter of. So there's a lot going on here right now. Excuse me. So what I need is the outside edges, like this side, this side, this side, and I can add them up to get the perimeter. So let's look at just figuring out what LK is. And then we'll figure out JK, and we'll handle JL in just a minute. Okay, so I want to look at just LK. I don't know anything about LK, but I do have these mid-segments. And what I know about mid-segments is that a mid-segment is going to be parallel to one side. And whatever side it's parallel to, it's going to be half the length of that side. So MO is going to be half the length of LK. I know that MO is 22. And what's 22 half of? Well, if I look here, LK is already split into two, right? It's split into two congruent pieces because N is its midpoint. So what that tells me is that this and this are congruent, and this is half of the whole thing, so this is equal to half, so it should be congruent to LN and NK. So MO is 22, LN should be 22, NK should be 22, and so LK from here to here should be 44. We're going to do the same process with JK. So here's JK. Here's the mid-segment. That mid-segment should be congruent to half of the triangle side. So if this is 25, then this is 25, and this is 25. Add those together, and JK should be 50. All right, and now let's look at JL. So we're going to use that same logic, that this is equal to 2 of these, or this is half of this. So I have that JL is double the length of NO. Okay? Well, I don't have a length for those. I just have some expressions. So JL I have is 5x minus 34. And NO I have is x plus 4. And we're just going to start simplifying. So we have 5x minus 34 equals 2x plus 8. Okay, we're going to subtract and get 3x. I'm going to add 34 and get 42. Divide by 3, and x is 14. Okay, I need the whole length, JL, which is 5x minus 34. So we're going to plug in 14. So 5 times 14 minus 34. And we get 36. Okay, so JL is equal to 36. And then to get the perimeter, I'm going to add those up. So 36 plus 44 plus 50. And the perimeter is 130. Okay, so I'm going to clear this out. We're going to, so that's everything for triangles, but we're still going to use these triangle skills on our next page, which is kites. And I know everybody really, really, really loved kites. That was everybody's favorite. Okay. All right, so some important things about kites. You have 2 sets of consecutive congruent sides. So what that means is that AD and AB are going to be congruent. So I'm going to mark these as congruent. That also means that DC is congruent to CB. Mark these. Okay, so these 2 sides are congruent, these 2 sides are congruent. We have, now these 2 sides obviously are not congruent. So that's important too. If these two sides were congruent, then this would probably end up being a parallelogram. Oh, maybe not, maybe not. Not necessarily. Not sure. I'm gonna have to look. Okay, let's see. Also, we have a set of opposite angles that are congruent. So this angle here is going to be congruent to this angle here. And that makes sense because we've got these two sides that are congruent and these two, or if you look at the angle, it's formed with a yellow and a pink. This angle's formed with a yellow and a pink. It's two, they've got the same sides, and then they share this side, so they're like two congruent triangles. So really, you have this triangle and this triangle are congruent, this big triangle, this big triangle. These two little triangles are congruent, these two little triangles are congruent. And then your diagonals form right angles. They're perpendicular. So you've got 4 right triangles, these two are congruent, and these two are congruent. So that kind of helps us when we start doing some of these problems. Okay, we're going to do a side length one first. We're going to find all the sides on this, and then these we're just going to worry about angles. So I'm going to kind of scoop this to where we're just focusing on one, and we're just going to do some side length work. So since we have some right triangles, we know that we can use Pythagorean theorem to find missing sides. So I'm going to put right triangles leads to Pythagorean theorem for sides. Okay, and if we don't remember, Pythagorean theorem is a squared plus b squared equals c squared. And c is always the hypotenuse. It will be the longest side of your triangle. It's also the one that is not touching the right angle. So if this is your right angle, this would be a leg, this would be a leg, this is the hypotenuse. Okay, if you've got a right angle here, leg, leg, hypotenuse. So, let's see. Okay, so we are given the following side lengths. We have that BD is 16. We have that AB is 13. And we have that EC is 28. Okay, so I want to find, let's just find all my missing side lengths. Let's have some fun with this. If BD is 16, so remember what I said about these being congruent triangles? And that makes sense because we have a hypotenuse is congruent to a hypotenuse. They share this leg. So this leg should be congruent to this leg. If BD is 16, we'll cut it in half. And this will be 8. And this will be 8. Okay, so let's find our missing side lengths. Now, I know that AB is 13. So AB is congruent to AD, so this should also be 13. So really and truly, I am missing AE. Let's see, I'm trying to find some room on here. Did not think this through when I made it. We are missing AE, and we are missing DC, which is congruent to BC. So I'm missing DC and BC. Okay, so let's do some Pythagorean theorem. Let's look for AC first. I'm sorry, AE first. And I can get AC once I have AE, but I'm not real worried about it. So this is a missing leg. This is my hypotenuse. We're going to plug in. We've got A squared plus B squared equals C squared. I'm missing a leg. I'm missing this piece, so I'm going to leave A open, plus my other leg is 8. My hypotenuse is 13. Okay, let's get some now it's just calculator work. So can't do anything about the A. 8 squared is 64, but if you didn't know that, you can do that. And 13 squared is 169. We're going to subtract 64. We get 105. And a squared is 105. So to undo a square, we have to take a square root. A lot of people were thinking that you had to square 105 and you get some huge number. But remember, this is after a has been squared. If we square a, then we know that it equals 105. So to figure out what a is, we have to take the square root. So square root of 105 is not pretty. It is 10.25-ish. Okay, so that would be this missing side. Now let's look for BC. BC is a hypotenuse. So I'm going to plug in my two legs. So 8 squared plus 28 squared equals c squared. And I'm going to kind of put both of them in the calculator and save some time. 8 squared plus 28 squared is 848. And we're going to take the square root of 848. And C comes out to equaling about 29.1-ish. Okay, so not pretty, but doable. And that's it for sides. That's as complicated as kites is going to get for sides. Let's look at angles. Okay, so again, we've got lots of stuff going on. I'm going to list out all the angles we're looking for. We go up to 10, I believe, on this. Okay, so we've got a lot going on here. The first thing that we want to remember is that the diagonals are perpendicular. They form right angles. So let's take care of those four right off the bat. So that's angles 4, 5, 6, and 10. So all four of these angles, 4, 5, 6, and 10, are 90 degrees. And I didn't do any math here. That is the definition of a kite. For it to be a kite, these diagonals have to be perpendicular. All right, so let's look at finding some of these missing angles. We have some angles that are going to be congruent, and then if they're not congruent, then it's going to be us looking for, then we have to use triangle sum, that all things add up to 180. Okay, I lost my pad of sticky notes somehow. So, oh, that one didn't have anything on it. That works. Okay, so let's just look at the first triangle. Now we have that this is 90 degrees. This is 18 degrees, and we're looking for angle 1. Okay, so we don't, we know that all angles add up to, or all angles in a triangle add up to 180. So, I'm going to put 90 here because we know that's 90 degrees. So we're going to do 18 plus 90, 108. 180 minus 108 is 72. Okay, I'm running out of room writing. I know some people wanted it written, but I'm hoping me doing it in the calculator will be enough. So angle 1 is 72 degrees. We're going to put that here. Okay, and again, I don't like to have a whole lot of stuff. I would normally like to have stuff covered up, but I'm going to leave this triangle open because remember what I said earlier, we have two congruent triangles right here. This side is congruent to this side. This is a hypotenuse and a hypotenuse. They share this leg. This is a 90 degree. So if I have two congruent triangles, then I should have some congruent angles. So angle 1 is going to be congruent to angle 2. Also, the diagonals bisect angle F and angle H. So that's going to be helpful too. So angle 2 is going to be 72 degrees. And because they're congruent, or because the triangles are congruent, we're using CPCTC. 1 and 2 correspond, 18 and 3 correspond. So this is also 18 degrees. So this is just recognizing that this triangle and this triangle are exactly the same. So 2 is 72 degrees and 3 is 18 degrees. All right, and now we need 7, 8, 9, 10. So let's cover up this triangle and this triangle. And again, so I have that this is 43 degrees. I have angle 10 is 90 degrees. So how do I find angle 9? So what we're going to do is we're going to add 90 and 43. And we get 133. And then we're going to do 180 minus 133. And we get 47. Okay, so that's angle 9 is 47 degrees. I'm going to remove all this. This one lost its sticky. These are two congruent triangles. So we have some corresponding angles. We already said that angle 6 is 90 degrees. 7 and 9 correspond with each other. So this is so 7 is also going to be 47 degrees. And that leaves angle 8 as 43 degrees. All right, woohoo! So there we go. So that kite has been handled. All right. We're going to do one more kite, and then we're going to move on to some parallelograms. Okay. So this one, I also want to do some practice with naming angles because we struggle with that. So remember, this middle variable is our vertex. So angle LON, O is our vertex, okay? So if I just say angle O, I don't know if we're talking about angle 8, angle 7, or this big angle that contains both 8 and 7. So there's 3 different possibilities for angle O. So that's why we have to use 3 letters most of the time. So looking at LON, O is the vertex. We go from O to L and from O to N. So O to L, O to N. This is the angle we're looking at. We're looking at the whole angle. So angle LON is 70 degrees. Okay. And then we have angle LMN. So, M is our vertex. We have to go to L, and then we have to go to N. So starting at M, we're going to go to L, and we're going to go to N. So this whole angle is 46 degrees. Okay, and we are looking for the measures of angle. We have 9 here. So measure of angle 1, 2, 3, 4, 5, 6, 7, 8, and 9. And part of me is like, I should have written this so you didn't have to watch me write this part, but that's okay. We're okay. All right. So let's look at what we know. Okay, so remember how I said we've got congruent triangles. So that means angles 2 and 4 are congruent, and angles 8 and 7 are congruent. So let's look at 2 and 4. We know that 2 and 4 are congruent, and they have to add to 46. So in some of these others, like if I knew what MLO was, I couldn't cut it in half because this line doesn't bisect this angle. We know that it bisects this angle though, because these two triangles are congruent, so 2 and 4 have to be congruent. So 2 and 4 are congruent, and they have to add to 46. So what we're going to do is we're going to do 46 divided by 2, and that gives me 23. So 23 and 23. And again, all of our angles around P should be 90 degrees. So we're going to make this 90 degrees. Okay, so now we can focus on just one triangle at a time. And let's focus on this triangle. We have that angle 3 is 90 degrees. Did I already put that? No. Okay, we're good. And angle 2 is 23 degrees. So to get angle 1, 90 plus 23. 113. 180 minus 113 is 67. So angle 1 is 67 degrees. And because this triangle and this triangle are congruent, angle 5 is also 67 degrees. Okay, so what I'm going to suggest you do is I'm going to suggest you pause the video and try to do 6, 7, 8, and 9 on your own. It's going to be the same process that we did right here. So I'm going to pause my video and, well, y'all pause your videos too, and that should give you some time to get these down. Okay, here's my answers. I got 35 degrees for 7 and 8 because you cut 70 in half to get these. And then you do 35 plus 90 and subtract it from 180 to get 55 for 6 and 9. And another hint that might be helpful, you don't have to use this, but for a right angle, or for a right triangle, excuse me, right triangles, you know that one of their angles is 90 degrees. Well, 180 minus 90 is 90. So the two other angles, so let's call this A and B, on a right triangle, this only works for right triangles. So in a right triangle, A and B have, oh, y'all can't even see that. So a right angle is 90 degrees. A whole triangle adds up to 180. So if you subtract out the right angle, you're left with 90 more degrees. So you've got 90 degrees here. These two have to add up to 90. So in a right triangle, instead of subtracting from are adding 90 and subtracting from 180, you could just subtract from 90, and it might make your math go a little easier and a little faster. But hey, if this is confusing for you, you can just kind of ignore it and forget I said it, and just erase it from your brain. Okay, the last shape that we're going to do is parallelograms. And we're going to kind of use the same things from kites and from triangles. I'm going to work with sides and angles, but we're just kind of doing the same math over and over again. We are just adding things up to equal 180 degrees. I want a sign in here that says like all roads lead to 180 degrees. We'll see. I don't know. I need something. That could be one of our end of the year projects, is make Miss Gallant some stupid, silly math posters. Alright, so let's start with just a basic parallelogram. So some things to note is that these two sides will be parallel and congruent. Now, if you remember things about parallel lines, parallel lines, when cut by a transversal, will cause some different angle relationships. You'll have some supplementary angles, and you'll have some congruent angles. And yeah. And then you also have these pair of sides that are also congruent and parallel. Let me mark these as congruent as well. So these are parallel and congruent. Okay, and so some other interesting things are that your angles across from each other are going to be congruent. So D and B are congruent, and A and C are congruent, and A and D will add up to 180, A and B will add up to 180, B and C will add up to 180, and C and D will add up to 180. So any two angles beside each other on a parallelogram. Now when we get to parallelograms and we have like extra lines in here, we have to remember that the entirety of that corner is what I'm talking about when we get to here. So like here, all of angle E plus all of angle F would equal 180. All of angle E would be congruent to all of angle G. So we have to keep that in mind, that that's what I'm talking about when I say angles on a parallelogram. The split angles and these angles in the middle are not necessarily what I'm talking about. I'm talking about just strictly in the parallelogram. So these will be congruent, these will be supplementary. All right, so let's start with, we have the measure of angle A is 119 degrees. AB is 45. BC is 31. So if I want the missing sides and angles, I'm not going to make a list because I want some room for some math. Let's start with angles first. I know that angle A and angle C are going to be congruent, so this should be equal to 119 degrees. All right, let's look at angle B. Now, if these two are congruent, then these two are congruent. So B and D will be equal. And I also know that A and B should add up to 180. B and C will add up to 180. C and D will add up to 180. D and A will add up to 180. So what I'm going to do is I'm going to do 180 minus 119. And that gives me 61 degrees. So angles D and B are 61 degrees. Okay, now looking at sides. AB is congruent to DC. So if AB is 45, DC is 45. BC is congruent to AD. So if BC is 31, AD is 31. Okay. So something else to note is that when you have diagonals, so if I have a diagonal, and let me get a, let's see, do it in green. Oh, not that. I meant the highlighter. Let's say I have a diagonal and I connect from A to C, and then I connect from B to D. Those diagonals are going to bisect each other. Let's call this point E. DE is going to be congruent to EB. EC is going to be congruent to EA. Okay? So let's look at this. We have, looking at our side lengths, one congruence mark to one congruence mark, 4 to 4, 3 to 3. We have two congruent triangles. So this whole triangle is congruent to this whole triangle. And this whole triangle is congruent to this triangle. So we've got some congruent triangles, which means we're going to have some congruent angles in here. Now, the diagonals, even though they bisect each other, that does not mean they bisect the angles. So these angles aren't necessarily cut in half. This is 119, but that does not mean it's split. You know, that does not mean that this is 59.5 and this is 59.5. In fact, if you look at it, this looks a lot smaller than this angle. What it could be, this could be a 30 degree, or let's make this easy. Let's say this could be a 100 degree angle and a 19 degree angle. Try and go with easy math. So it doesn't split, the diagonal doesn't split the angle evenly. It just splits it into two. So it's not two congruent angles here and here. But let's say this is 19 and this is 100. Down here, it's an alternate interior angle. This would be 19 and this would be 100. So whatever it splits it into on this side, it splits it into on this one too. Okay. So let's kind of get away from that. We're going to do some math here. I have some angle naming practice as well. So we're going to start with, actually, we have some missing sides too. So let's handle these sides first. So we have HG is 9. This is going to be congruent to its opposite side. So this is 9 as well. FG is 17. So EH is going to be 17 as well. EJ is 13 because diagonals bisect each other, then JG is going to be 13 as well. And then we have HF is 22. So if HF is 22, that means that HJ is 11 and JF is 11 as well. We're going to cut that in half to get this piece and this piece. All right, so we got all our side lengths taken care of. Let's worry about some angles. Okay, we have that EFG. So F is our vertex. We have E, F, G. So we start at E, go to F, go to G. All right, this whole angle is 72 degrees. So this is 72 degrees. Now that does not mean that this is 36 and 36. It could be 30 and 42 for all I know. I don't know anything yet. We're going to figure that out. Now, because we've got congruent angles, if this is 72 degrees, then up here, this angle is 72 degrees as well. We have H, G, J. So H to G to J. This angle is 51 degrees. Okay? Now, this is 51 degrees. We know that this line is parallel to this line. So if I look and treat this like a transversal and two parallel lines, this is an alternate interior angle with this. So GEF is also 51 degrees. So if this is 51, then this is 51. This is congruent to this. Okay, FHE. So F to H to E. Woo, that was kind of, highlight that. F to H to E is 25 degrees. Okay, and again, this is parallel to this. So alternate interior angles, we have this angle is congruent to this angle. So this angle is 25 degrees as well. Okay, so that's everything we have so far. Okay, so let's see, what do we know? We know that this angle right here, we know that this angle is 72 degrees and that this half of it is 25. So we're going to, or this piece of it, let me not say half. So we're going to do 72 minus 25. And we get 47. So let's make this 47 degrees. Now if this angle is 47, we're going to come down, alternate interior angles. This is 47 as well. All right. So now we have, now we're missing, we can't do, well, we can figure these out, but I don't feel like it. Let's get this angle and this angle. These are the last two angles I want to worry about. So what I know, I don't know if you remember what I told you about this earlier. If we have 119 here, we can figure out this angle by subtracting from 180. So if this angle is 72 degrees, then to get this angle, I have to subtract from 180. So 180 minus 72. $108. Oops, sorry, not here. Right here. 108 degrees. Alright, so this whole angle is 108 degrees. Now if I want this piece of it, you see how this piece is 51? So we're going to do 108 minus 51. And that leaves me with 57 degrees. So this angle right here is 57 degrees. And if this angle is 57, then this angle is 57 degrees. Okay? And this angle right here would be 108. If you added 57 to 51, you should get 108. Okay, and then if you want these middle angles, so we got a lot going on. If we want these middle angles, actually, let's go ahead and just figure that out. We only have to, once we figure out one, we can kind of figure out the rest of them. So we have, this one's messy. Let's do this one. We have a triangle. Now, not necessarily right. I actually don't think it is going to be right. We have that this is 47 degrees. This is 51 degrees. All angles add up to 180. So we're going to add 47 to 51 and subtract from 180. So 47 plus 51, and then we're going to do 180 minus that. And we get 82 degrees. Okay, so this is 82 degrees right here in the center. Okay. So if this is 82, by vertical angles, this should be 82 as well. Those would be congruent. These two should be congruent as well. And if we cover stuff up again, whew, if we cover this side up, we see that this angle and this angle, 82 and this angle, form a linear pair. So let's do 180 minus 82, and we get 98 degrees. So this would be 98, and this would be 98. Okay, so looking at, and that's it. That's every single angle, every single side on this parallelogram. Okay, I have one more for you. I'm going to list our angles out, and I'm going to let you guys figure it out. You also have that angle KLN is 102 degrees. So let me make sure y'all can see that. And we have 10 angles we are looking for on here. Okay, so let's see. I don't know if you can see the entire problem and all 10. There we go. Whew. Okay, so I'm going to freeze my screen, do my work, and I'm going to let y'all, I encourage you guys to pause the video and try this problem and then check your answers. So good luck. Okay, guys. I made a mistake while writing the problem. Not necessarily made a mistake, but I didn't give you guys enough info. I think I had KLN as 102, which is great, but you could have figured that out already. I think I meant to give you a different angle. So, let's see. Just gonna make sure I can come up with something that's not good, that's gonna work. Let's see. You know what? Let's make angle 10 degrees. Let's just do that. Maybe I meant to make that 10 degrees instead of just 10. So angle 10 we'll do is 10 degrees. And then now you can finish out this problem. So hopefully you got all of these angles with the exception of 10. And so good luck on the rest of the problem. Okay, so if you make angle 10 degrees, then yeah, this works. So here's your answers. Sorry about that snafu. It's what time is it here? Okay, it's 6 o'clock and I'm still at work, so yeah, my brain is done. Okay, anyway, I hope this helps you guys out some. I hope some people watch this because, you know, I did make it. You guys have a good evening, have a great long weekend, and I will hear from you guys soon. Bye!